Hey, good morning, everyone. Let's start with today's session. I hope my screen is visible, right? Can I get a confirmation from anyone? Okay. Yeah. So, today's agenda, what we'll be covering today are like transformers in practice mostly. So, what we have different model families of transformers like BERT and GPT and T5. We'll be doing a comparison between all of them, and then we'll be looking into the Hugging Face ecosystem. How pipelines work, model hub, and datasets library, what are there in the ecosystem and all. And finally, we'll work on a lab project in fine tuning a project, and then a generalization project and a summary generation project as well. Okay, let's start with them one by one. So first, we'll see the major difference between BERT, GPT, and T5, the three major transformers. So, in architecture wise, what is the major difference between BERT, GPT, and T5? So, BERT works on a like encoder only architecture. Okay, so encoder is basically the understanding part or the input part of a model, and decoder on the other hand is the generation or like the output path of the architecture. Okay, GPT is the decoder only architecture, and T5 is a combination hybrid of encoder decoder architecture. So how the mechanism works is basically BERT works on a bidirectional context. Basically, it sees the entire sentence at once. So it works on something called as the Marx MLM. Okay. On the other hand, GPT works on unidirectional or casual context. Okay, so what it means is it only sees the past tokens, not the future tokens. So it works on a casual CLM model. Okay, casual LM or CLM model. On the other hand, the sequence to sequence hybrid model of like T5 that works on a bidirectional encoder plus casual decoder combination of both model. Okay, so it spans the corruption. So what are they ideal for? Not that like any one is good for everything. They have their own use cases for everything. So BERT is usually ideal for understanding. For example, like classification, NER, QA, sentimental analysis, those kind of tasks, because it is a encoder heavy architecture, right? On the other hand, GPT is a generation based model. It's ideal for generational tasks. For example, chatbots, storage generation, code generation, those kind of things. Like the chat GPT you see, that is a GPT model, right? So it's used for generation, code generation or like text generation, those things. On the other hand, something like T5, which is a mixture of both, is good for something like translation or like summarization, paraphrasing, those kind of tasks. They're ideal for. Now, what are the pros and cons of each model architecture? So BERT is very much rich in context. Okay, but the downfall is that it can't generate text because it is a encoder only or like understanding only model. It doesn't have a decoder, so it cannot generate any text. Okay. On the other hand, GPT model is like it gives very fluent output, but the NLU score is very low because its understanding level is quite low. It doesn't have a encoder in it, right? And finally, the T5 or the BERT model, which has both encoder and decoder, is best of both because it has both encoder and decoder. But you can like guess what the downfall in it is going to be, because since it has both, the training time for it is gonna be slow as well. Okay, so the BERT and GPT basically fastens the training time by skipping one side of the architecture, either the encoder or the decoder. The attention mask in BERT is actually full, in GPT, whereas it is triangular, and in T5 it's kind of progressional, like full to triangular, like depending on the architecture. The encoder side is full, and the decoder side is triangular. Okay. Next, we'll cover what are like the pre-training objectives. Basically, how models learn language structure without explicit labels. Okay, here we don't have explicit labels, but still, how do models learn the structure, language structure? Okay, so there are three basic ways. One is the MLM or CLM or sequence to sequence denoising. So MLM, what is MLM? It's basically masked language modeling. So the model must predict masked tokens based on bidirectional context, either left and right, like a close. It test the close one by one. Okay. Whereas in CLM or casual language modeling, it predicts the next token based on the previous token. It's a unidirectional flow, and it's very much essential for generational task. Okay. On the other hand, a sequence to sequence denoising, it spans corruption. Basically, it replaces chunks of text with sentinel tokens, which is very much good for models that generates the missing spans. Okay. Now we'll see what is NSP. So NSP, or like next sentence prediction, it's basically like in the original BART used NSP to learn relationships between sentences. Example for QA or NLI, those things. Input can be something like starting with the CLS, which basically says the classifier sentence. Then we have like a sentence A. Then we have a separator token. Then we have like a sentence B. Then multiple sentences can be separated by the separator token, and it is always starts with a CLS token, which represents the start of the uh, sequence. There was also Roberta and modern models. So what they were about? They dropped NSP. They found that training no longer was like contiguous sentence with dynamic masking was sufficient and more than sufficient. Okay, so they dropped the NSP part. Now we'll see the objective versus capability of BERT, GPT, and T5. So we already discussed in the previous slide as well. BERT, or like a MLM based model, is best for understanding. GPT, or like a CLM based model, is best for generation, and T5, or a sequence to sequence based model, is best for like universal interface. Now let us explore a bit about the model families snapshot. Okay, so navigating the zoo, which architecture fits your task? Okay, we are going to explore that. So first we have encoders only architecture, which is basically used for understanding purposes only. Like if we have a understanding heavy task, which uses bidirectional context, based for classification, NER, QA. And what are the different types of options of models we have? We have like BERT, we have Roberta, we have distilled BERT. So these are all the pre-trained models which we are going to use, and which we have the options to use, right? Next, in decoders only, which are uh, specified or like very good for generation based task. It's a unidirectional or like casual flow, and it's based for text completion or creative writing. What are the different options we have for decoder only models? We have like GPT-2, GPT-3, Llama. Those are like the top choices people use for decoder only or like generational based models. Next we have encoder, decoder, combinational sequence to sequence models, which are based for translation based tasks. Uh, it is best used to process input to generate new output, and it's best for translation, summarization, etc. And what are the best options we have for this genre? We have like T5, BART, Marianne MT. These are the best models we have for translation purpose or like encoder decoder architecture. Now, for lab purpose, uh, the best models we should use so that we don't get a out of memory error, which have lesser params and which gives good accuracy. I have specified three models here. So if we want to do something like a classification based task, we can use distilled base uncased. Okay, it has like 66 million parameters around. Then for generation based task, we can use distill GPT-2, which is almost 82 million parameters. And for summarization based task, we can use something like uh, slifer distill but CNN 12x. The model is like listed here, you can check the name. So this all of these models are like hosted in the Hugging Face Hub library. We can just import or like install from that library. So it's very easy to use, and it has just like 306 parameters, 306 million parameters, which is uh, not that much as compared to other generation models. Okay, so these are like the free tier models that you guys can practice on. Next, we are going to see a API pipeline for NLP in one line, very short task. So what we are going to do, we are going to do the magic import, the pipeline function, which is a high level factory that handles the tokenization, the model inference, and decoding automatically. Okay, so first you see in this line we have imported the pipeline from the transformers library. Then we are defining the classifier as pipeline of sentimental analysis, right? So we can directly select the task as like sentimental analysis, and it automatically downloads a SOTA model if none is specified. So here we have not specified the model, and it will automatically download the SOTA model. SOTA basically means state of the art model, so which is identified as the best model according to the different accuracy scores and different measurements. Like this is the best model for this purpose, that is considered as the SOTA model. So it will automatic the pipeline function will automatically import the SOTA model even if you don't specify. Next, we can select the model optionally. So from the hub, the model arguments we have, and like in this line you see the fill is basically a pipeline function again, and we're masking, and we are specifying the model name here as well. So it is optional. If you want to specifically use a certain model, you can just call that model as well and use that model as well. And finally, we'll be doing the inference. We call the pipeline object directly on the raw text. No manual tensors conversion is required. In this line, if you see, we are calling the pipeline model, and we are doing the summarization on the text. This is the text that we are given, and in the future slides, we'll directly see a lab example as well how this is happening. Okay. Now we'll look more into loading models and tokenizers. So the auto class abstract away architecture details and handling configs and waits automatically. Okay, so it has three things actually: the auto tokenizer, auto model, and smart caching. So what is auto tokenizer? It loads the vocabulary, example like vocab.text, and merge rules associated with the checkpoint, handles text normalization, padding, and truncation. Okay, so a tokenizer will be something like auto tokenizer dot from pre-trained of but base uncased. Okay, so it basically how the tokenizer is being initialized from the pre-trained, not the pre-trained, from the existing library of auto tokenizer. Okay, we are calling the from pre-trained function. Next, auto model. So what is auto model? Auto model loads the configuration, basically the layers and dimensions, and the pre-trained weights. Example like pytorch model.bin. This is like how a pre-trained weights file looks like a .bin file. Okay, and it initializes the correct architecture automatically, so that you don't have to, like, train everything from scratch. It initializes or loads a pre-trained weighted architecture automatically, and it looks something like this: model equals to auto model dot from pre-trained of but base uncased. Okay, but base uncased is basically the name of the model, and auto model is basically the library from which it is being called. Next, we have smart caching. So files are downloaded once and stored in a like dot slash cache slash hugging face folder, and subsequent calls load from the disk instantly. So it doesn't always call from the library. It stores in a cache. Okay, so you don't have to again and again call from the, or like download the files. Now, some performance tips from my end, which I've already, I think, shown you in the last class also. Whenever you use or you train your models, transformer based models, always use a GPU based runtime instead of a CPU based runtime. You can use enable the T4 GPU runtime, and I have shown in the last session as well how you can do that and how you can check if your device is running on GPU or CPU. Okay. So this is the lab project that we are going to see today. It is basically a sentimental analysis. We have a IMDb dataset, and this dataset we are going to load, train, and then test, and we are going to see, if some sentences are positive or negative. Okay, we are going to shift to Collab notebook now. So this is the Collab notebook. I have already run the sentences so that it saves some time, because the training part took some time actually. So I'll just explain you what is there in the code. So first, we all, as always, install the transformers, data sets, accelerate, and those libraries. We import the IMDb dataset. We separate it in the form of train and eval datasets. It's like similar how we have been doing it till now. Till this part is pretty much similar. Here, I think you would remember this part. We are loading a pre-trained model checkpoint, which I've shown you in the last class as well. So we are loading a pre-trained checkpoint so that we don't have to train the model from scratch. Next, from auto model from sequence pretend we're loading the module checkpoint, and we're labeling as num labels as 2. Here we are computing the matrix. Okay, these are the training arguments. So output directory is basically where we want to store the results. Results are basically, after fine tuning the model, we'll get a new predefined weights of the model. Okay, so those are the results. So if we want to again train on those weights, or continue our training maybe some other time, we want to store those weights somewhere, right? So we are storing it in the output directory, which is slash results, and later we can just open that same folder again, load that weights, and continue training on top of it again. Okay, so this is the trainer, and we are calling the trainer function, and the training happened here. This is the matrix which shows us the evaluation loss, the accuracy, the F1 score, the runtime, and those matrices as well. So this is the confusion matrix of the model that we have just trained. Yeah, this part is the important one. So here we are calling the model we just trained. So this is the pipeline where we are calling the text classification model, and model we are loading from the saved directory. Tokenizer we are also using from the saved directory, which we have saved after training the model in our saved directory. Okay. Next, we have given a demo sentence. Three demo sentences we have given, test sentences, like this movie was absolutely fantastic, a masterpiece. I fell asleep halfway through. Terrible film. Great action, but great acting, but boring story. So three sentences, and we want the model to predict if those are positive sentences or those are negative sentences. And just informing you guys, in IMDb data set, label 1 is defined as a positive sentence, and label 0 is defined as a negative sentence. Okay, the negative sentence basically means it is a negative review, and positive review basically means uh, label 1. So if you see in the output result, you can see this movie was absolutely fantastic, a masterpiece. The prediction is level 1, which basically means it is a positive review with score, or like positivity of 90%. Whereas the second sentence, which says I fell asleep halfway through, terrible film, it says it's level 0, basically in a negative review with a score of 88%. And finally, which is a bit in the between, confusing, like great acting but boring story. There is a praise as well, there is a con as well, telling the bad review as well. So here also the model was able to uh, detect it quite well with a 73% accuracy, that is a negative review overall. Okay, so this is the text generation lab project that we have seen today. Next, yeah, we have another project, that's the summarization project. So this is the summarization project. So it's quite simple. So it's basically importing and installing the existing libraries. Then we are just checking the transformers version, and finally from transformer, in a pipeline we are calling the summarization uh, task, and the model, the sh lifer model distilbart cnn 126. And what we are giving it the task, like summarize this whole sentence. Okay, this long sentence of like around 50 to 60 words into a smaller, like max length of 30. You can play with these numbers as well. If you have like a very big Wikipedia uh, summary of maybe thousands of words, and you want to summarize it into like maybe 100 words, you can do that as well. You just put that phrase here in the text. Okay, you call the model with max length of 100 or like 150, whatever you want. Here I've just given 30 for this 50 to 60 words uh, text, and it gives the summary as like artificial intelligence has rapidly transformed industries over the past decade. However, ethical concerns and job displacement remains key challenge, which is a pretty good summary of this big text line here. Okay, so this is our second project as well. So we have covered two mini projects in this lab. uh, so these are all these two. Yeah, now we will see the decoding strategies and compare them. Okay, so there are majorly three decoding strategies that we use: the greedy search, the beam search, and sampling. Okay, yeah, sorry. So the greedy search, the concept and mechanism behind greedy search is that it always picks the highest probability. The nature of it is deterministic. On the other hand, beam search explores multiple paths and it works on a heuristic search. And sampling, it randomly picks from the top. Its nature is like stochastic or like random. So greedy search is best for short or exact results, like arithmetic, factoroids, those things. Beam search, on the other hand, is good for translations or like summary. It's like standard for quality. Sampling, on the other hand, is best for creative writing, like stories, chatbots, etc. Now, what are the pros and cons of each of them? So, greedy search is very much fast and efficient, but on the other hand, the con is that it's very much repetitive and boring. Beam search is coherent and grammatical, but the con is that it's very compute heavy. Sampling is very diverse and human like, since it is used in chatbots and stories and everything. But the cons is that it has very high risk of hallucination. Okay, if you want to see visualization of the three algorithms, it something looks like this: greedy search looks like this, beam search looks like this, and sampling looks like this. Now I have a small task for you guys. Okay, you guys have to uh, predict which one is the best for each of these tasks. The first one, which decoding strategy are you going to use? Okay, you guys can answer in the comment section. I mean, in the this one chat, or in the speaker as well, as you guys like. So first one is like a code generation. You are building like a AI coding assistant. The user asks, write a Python function to compute the Fibonacci series. So precision is crucial. So for this task, which decoding strategy will you guys use? Greedy search. Okay, from Lakshmi Shriya. Anyone else? Any more answers? Harshini also says greedy search. No more answers. Others are not much active today, huh? Okay, another greedy search. Okay, greedy search is actually the correct answer. So, big round of applause for Lakshmi Shriya, who gave the first correct answer. So, for precision and code generation, those kind of tasks, greedy search would be the correct decoding strategy. And next we have machine translation. Okay, translating a formal legal document from English to French. That is the task. You need high quality sentence structure and grammatical correctness. So, what algorithm are you going to use? Any answers? Beam search from Lakshmi Shriya again. Beam search from Hashika R. Hansika SM as well. Okay, nice. Naveen Kumar also says Beam Search. Abhiram also says Beam Search. Sai Tarunvi also says Beam Search. Ravi Karan also says Beam Search. Correct. That is actually the correct answer. So again, a big round of applause for the first answer given by Lakshmi. Nice, nice. Next is creative writing. So it's basically the task is generating unique marketing slogans for a new cyberpunk energy drink. You want variety, novelty, and non-repetitive text. So what decoding strategy are you going to use? Sampling, says Hashika. Hashika says sampling. Okay, any more answers? Rakshita also says sampling. Ravikarian says sampling. Hansh She also says sampling. Lakshmi says sampling. Navneet says sampling. Nidhi also says sampling. Okay. Shreyas also says sampling. Nice, nice. Sampling is actually the correct answer. So first answer is given by Hashika R. So big round of applause for Hashika R. Sampling is the correct answer. Nice. Great answers. I think you guys have understood the decoding strategies well since you are able to answer these things. Next, this is going to be a task I'm going to assign you guys. Okay, I'll submit. I'll take a screenshot of this page and assign it in the LMS. So you guys will have like two paths to choose from, either track A or track B, and do the projects accordingly according to your choice. No such, you know, hurry or like something that you have to do that only. You can choose your own. So this task I'll just put in the LMS. Next, I'll discuss about some of the common pitfalls and troubleshooting. Okay, where NLP models break in the real world and how to fix them. One of the major pitfall is like something called as tokenizer mismatch. Okay, while using a BUT tokenizer with a Roberta model or vice versa, results in like gibberish input IDs. Okay, it's a silent fail. You won't be able to see that. So how do we fix that? Always match names like tokenizer equals to auto tokenizer dot pretend of the model name. Okay. Then another pitfall is silent truncation, which is a hit on your performance. So basically, what happens? Your BERT-based models have a hard limit of 512 tokens. Okay, long documents get cut off at the end. So how to fix that? Uh, Use like truncate only explicit or switch to longer form. Okay, and finally, another pitfall is that overfitting on tiny data, which is very much common in labs. So transformers are huge, like 100 million plus parameters. So fine tuning on 50 examples lead to 100% train divided by like 50% validation accuracy and all. So the fix on this is early stopping. You should know when to stop, freeze the encoder layers, or use more data. Okay, and attention is not always equals to explanation. Just because a model attends to a word doesn't mean it's the reason for the prediction. Okay, attention is a mechanism for routing information, not necessarily a saliency map for human interpretation. Okay, so some of the sanity checks you can do are like, did you check max length coverage? Is the data balanced? Are you shuffling the training set? Did you use strategy equals to y in your split? Is the learning rate small enough? Example like 2 to the power minus 5. Those things you can check. Finally, we have a quiz and then we'll wrap up with today's session. So the first question is, what is the primary advantage of self attention over standard RNNs? Okay. Option A, requires less memory. Option B, parallel computation and global context. Option C, processes inputs sequentially. Okay. So have you guys got the question? I'll give you guys like 30 seconds to answer this. Let's see who is able to answer the fastest. We'll have a very rapid quiz now. Okay. Okay. First answer is given by Hanisha SM, parallel computation and global context. Let me check. What is the primary advantage of self attention over standard and parallel computation and global context? Yes, that is the correct answer. Option B, parallel computation and global context. Okay. So big round of applause for Hanisha SM who gave the first answer. Also answer given by Hashika R, Harshini K, B correct, Sreyash HR also correct, Rakshita correct, Yashwant correct, Babyashi correct, Nidhi also correct, Navneet also correct. Nice. I think you guys are understanding this concept now. Okay, let's go to the next question. So, which model architecture is decoder only and best suited for text generation? I think this is very simple. You should be able to answer in like 2 seconds. Before I switch to the next page, you guys should answer this. BERT, T5, or GPT? Good. Very fast answers. GPT, GPT, C, GPT, C, GPT. Correct. So the first answer is given by Rakshita S. So big round of applause for Rakshita. Correct answer. Sai Tarun also gave. Akarsh also gave right answer. Navneet also right answer. Nidhi, Harshika, Lakshmi, Shreyash, Bhavyashri, Anisha, Chirag, Bhavyashri, Yashwant. All correct answer. Correct. Nice. Nice guys. Next question. If your generated text is too repetitive, which parameter should you likely increase? Temperature, beam width, or minimum length? Okay, okay, lots of answers. So Akarsh gave the first answer, temperature, which is correct. Big round of applause for Akarsh. That's the correct answer. Also given by answers given by Ravi Karan, Yashwant, Navneet, Hashika, Lakshmi, Bhavyashri, Rakshita, Sai Tarun, Ni- Nidhi gave answer A only is temperature, right? Yeah, correct. Yeah, all of them gave correct answer. Right. Great, great, great guys. I think everyone great round of applause for everyone. You all gave right answers. Temperature is the correct answer. So the quiz is done. I have just final three takeaways from this. So first one is like attention is all you need. Like self attention replaced recurrence, enabling like massive parallelism of O of n square complexity, capturing long range dependencies effectively. That is the like the core takeaway. Okay, the tooling that is used in this session was Hugging Face ecosystem. Okay, so pipelines allow rapid prototyping and standardizes the workflow for thousands of models. And the application we had transferred learning works. Okay, so fine tuning small models like Distilbird, we saw like how we fine tuned a small model like Distilbird, and we worked on like uh, SOTA results, minimizing the computational as compared to like training from scratch and still having good accuracy on the generation and summarization tasks. So Yeah, those covers all about today's session. So we are done with today's session. If you guys have any queries, doubts, or anything related to anything that I have covered till now, any sessions or in general any doubts, you guys can ask me now, or we can wrap up with today's session. So anyone has any queries or any doubts? When is the interaction session? That will be confirmed by Rohit in the group. That will be taken by someone else, so it will be confirmed by Rohit. Please share the resources. So I have already shared the previous video lectures in the LMS already. In between there was some problem with the LMS, so I was not able to share last day's session, and today's session I'll share soon as well. So these things also I'll share. And I have also updated the tasks in the LMS as well. So you guys don't share me the outputs or the results of the task that you are doing in WhatsApp or anything. You guys just upload it in the LMS only. Okay, I have uploaded the tasks in the LMS as well, and I have given the last days as 20th March. So I have given plenty of time, as I guess. So I hope you guys will complete the task and upload in the LMS by then. Even today's task and last day's task I'll upload in LMS, and the last date will be 20 only. Okay, 20 March. After that we'll work on a major project, so I want all of these mini tasks to be done by then. I hope that's fine, right? Cool. Any more questions, any more doubts? The interaction session, I'm not so sure about it. It will be taken by someone else. So I think Rohit can give you guys more clarity on that. Okay. So he will inform soon in the group. Okay. The timings and what the interaction session will be about, he will inform soon. Anything else, guys? Okay. If not, can I get a thumbs up that we can wrap up, right? Cool, cool, cool. Okay, guys. Thank you for your time. Have a nice day. Thank you. Thank you, Rakshita. Thank you. Bye. Bye, guys.